So,
Yes.
shall we start?
Yes, I'm just asking you.
Okay. So, dear participant, welcome back. And this is our second session of the day 5. And this session topic will be the logit model. So, over to you. You can start.
Okay. Just So let's start. It says every day may not be good, but there may be something good in every day. So hopefully we will get something useful today. Let's see what's to begin with.
कान में लगती है ना ये आवाज। पता है कमाल की बात क्या है? ये चौक को ऊपर से हल्का सा तोड़ दो तो ये चू चू नहीं करती। एक छोटा सा टुकड़ा, एक छोटा सा चेंज, यही फर्क होता है क्यों में और क्यों नहीं में।
Small video clip, and it tells us difference between why and why not. And as a researcher, we must appreciate the difference. And that's very important. The moment you start questioning why not, then you will find that they are able to start thinking and start getting the answers to the questions and the problems. So always ask yourself, why not this? And that will make a difference. Another video clip from the same film.
They don't belong here. They never did. They never will.
They will sir. शायद हमने कभी कोशिश ही नहीं की that they do belong. You know what, Mr. Wadia? There are no bad students, only bad teachers. Chuck, chuck.
What does it convey to us? What does it say? What does it tell us?
Maybe we have to introspect.
Yes, Leena ji, please.
It tells that each one of us have to introspect ourselves,
Okay.
and handhold students,
Right.
and nurture them towards excellence.
Yes, because they are not bad students. And it is our responsibility that we have to improve ourselves, and we have to build our own capabilities as a teacher, as a researcher. And that's what we have to do. So every session which you are attending must be allowing you to build up necessary capabilities. And I hope that this session will also allow you to build up the necessary capabilities. If you're not capable, you cannot make your students capable. Okay? It's only that we are not taking care of our students. And if we start taking care of our students, you'll find they will be a wonderful lot which you can never thought of. Okay, so two things I am trying to convey through these two video clips. Always question, why not this? Okay, because that's important for learning. And second thing which is important for us is that we all are teachers and students are good. The only thing is we have to make ourselves good. Okay, so with this, let's go ahead and proceed with our agenda of the session. So now let's go ahead with our next item of the session's agenda. What's that? You might be curious to know what is it we are going to talk about. Have you ever wondered or have you ever thought what factors improve the chances of making a merger successful? Some of you might be working on mergers and they might be interested in knowing what is that which makes it successful.
So the synergistic approach.
Okay, Triveni, that's right, but how you will identify that factor is important or not.
We have to look at economies of scale in the sense, what are the
But
benefits?
how you will look at it? Triveni, that's a question, how you will look at it.
Yes, sir. We have to look from the point of view of production. For example, if it is the same product or the company with which we are merging,
Okay,
we have to look at the various factors affecting it.
right. So how you will know that which factor is important, which factor is not important?
No, we plan for merger only when we feel there is some benefit that we get with a company.
Okay, but how you predict that this merger is going to be a successful merger?
Okay, we have to we look at the valuation of the company.
Okay,
That is company A and company B, if they are merging, we value company A and we value company B. And overall, we look at what is the ultimate value of company AB after it is merged. We
okay,
have to evaluate the financial aspects also. We look at the financial
okay,
constraints as well as financial benefits that the companies are gaining by merger. And
right.
then we evaluate whether the merger is going to be
Okay,
successful or not.
Triveni, may I know your background?
Sir, I am teaching at Ramaya Institute of Management. I teach finance cases.
Okay,
Yeah.
right. Suppose I have to identify what factors make a successful merger. So what I will do, I don't know. You might be saying that the valuation, you might be saying the economics of a scale, you might be saying the synergistic gain, but out of that, which is more important? How do I know that? Which is the differentiating factor? How do we know that?
Sir, for example, we were talking about Vodafone and Idea merger.
Right. Do you think
So,
that is successful?
yeah,
Okay. What makes you to say that they are successful?
it is called
You
as
mean to say
BI.
that after merger, Vodafone is doing better?
It is now a different company called BI.
Huh?
They are having a good position in the market as of now.
Aruballa is saying when something is common between them. I don't know what he meant by something common.
So we have to check their profits post merger and pre merger, like.
Can I take your call? Just give me a minute. Wait. Namaste. बहुत अच्छी बात है. बहुत अच्छी बात है. तो वेरी गुड, वेरी गुड. ठीक है, 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 ठीक है. Okay. Sorry. Aru is saying when their objectives are common, objectives are always common, but the problem is common objective doesn't make merger successful.
But it can
Yes.
also be the tax benefit that we may get a tax reduction in the tax liability. If you have to go into
That's the motivation for mergers,
one of the factors,
right?
increase in
But is
financial
that
capacity.
important factor to make this merger successful?
Yeah, one of the factors can be tax
Are you
benefit
sure
or
that
tax.
it is important factor?
Not very important. Financial capacity of the company is very important. We look at how merger will help in
On
increasing
what
the
basis you are saying the financial capacity is more important? What is the basis on which you make this statement?
basis
So,
is
financial capacity of one entity and maybe the other attribute like marketing capability of the other company, both are strengths, and then that may result into good merger.
These are all conjectures, all guesswork. But as a researcher, what you will do in that case? Anyway, we will look at other problems as well. Say, sorry. Can we increase the profitability of making a company more financially sound by increasing its cash from operating to sales? Can we do that?
That is one of the factor. It can be done, but later, like the interest component has to be reduced, that in the capital structure.
Right. So do you mean to say that if the capital debt is going down, so company is becoming more profitable, more financially sound?
That has to be balanced. We cannot bring it down abruptly, but that has to be balanced.
But how to do the balance, that's one of the greatest challenge. Anyway, I'm not answering these questions. We will definitely like to answer these questions.
Sir, I
Have
agree
you
with
ever
this.
thought what factors make a person to invest in the stock market or not to invest in the stock market?
One is personal gain, sir, to make more money.
But how do we know? पता कैसे लगेगा कि वो आदमी स्टॉक मार्केट में इन्वेस्ट करेगा कि नहीं करेगा?
Factors which will motivate a person to invest is to make more money. The factors that will also not motivate him to invest is the risk of losing money.
Okay.
Sir, his need, his risk-taking capacity.
Rakshmi, whatever you are saying, do you think that makes a difference? Maybe a person is willing to take risk, capacity to take risk, but he's ignorant. He doesn't know about stock market.
Yeah, its awareness or education and profitability of the companies also matters.
Also matters तो है, पर एक्चुअल में है क्या? वो है क्या? वो पता कैसे लगेंगे? कौन से फैक्टर्स हैं?
So by analysis and research or by information.
अरे कहना आसान है, रिसर्च करो, पर करोगे कैसे रिसर्च? रिसर्च स्टूडेंट को कैसे बताओगे कि भाई तुम रिसर्च करो? वो पूछेगा सर कैसे करें, मैडम कैसे करें, तो क्या जवाब दोगे?
We have to study the cognitive aspects of the investor
Hmm.
and look at whether wealth creation is his.
Sir, movement in the share price in the stock market.
Right? Yes, Momita.
Yes, sir.
Moment.
Sir, investment in stock market will depend upon every person's risk and return perception. Like,
In general, sir, in generally, normal people, they study the movement of the share price in the stock
Okay.
market, and on
Right.
the basis of that information, they take their decisions.
But Momita, tell me how many people look at the share price data? Very few.
Actually, sir, broker actually study all these things.
Brokers do. Brokers do. That's right.
again, the information will play an important role what is available in the market.
So published by the companies.
Okay. Have you ever thought how Gmail is deciding which mail should go to spam or which mail should not go to spam? कैसे decide करते हैं?
इस मेल को हम इग्नोर कर देते हैं, हम ओपन भी नहीं करते, तो वो स्पैम में जाती है.
वो ऑटोमेटिकली थोड़ी आती है. जीमेल उसको पहले स्पैम में डालता है.
हाँ, जीमेल डालता है, ऑटोमेटिकली नहीं आती, बट इट डिपेंड्स ऑन आवर एक्शन, व्हाट एक्शन आई एम डूइंग विद एवरी डे विद माय मेल्स.
But there are certain mails which are coming for the first time.
They
They are
check
going
the
to
source
spam.
as well. So they
Yes.
check the source from.
Shishavati, right?
So Shashanita, yeah, if a certain
Shashanita, yes.
mail goes to a large number of persons,
What is commonality on these examples? There are two categories, okay? Successful mergers, not successful mergers. Spam and not spam. Okay, invest and not invest. So visualize that there are two things and you have to decide where a particular thing will go, whether it will go to this box or this box. How do we do that? That's the challenge which you are going to face. Of course, Gmail must be working on some algorithm, but that algorithm should be based on certain procedure, certain technique, right? Imagine what if the dependent variable is a binary variable. Okay, like the categories I was talking about. Invest, not invest. Sound company, financially sound company, financially not a sound company. So we want to use a binary variable as a dependent variable, and then we want to make a model. Okay, so we are showing something like, suppose I define a variable, say D, that will take a value 0. If it is failed, and take a value of 1 if it is successful, then D might be a function of number of variables. Then what to do with this? That's the kind of the problem which we are going to understand and which we are going to talk about. So first, appreciate the problem which we are going to use. Okay, again, I want to make a forecast. whether a company is going to be a sound company or not a sound company. Okay. I want to determine the factors determining the success or failure. Or I may be interested in classification. Suppose a person come with a request for a loan. Request for a loan. Should we accept that request? Should we not accept that request? Where we should classify that? Accept in the category of the acceptance or in the category of the rejection. Where we would like to put him. If you are looking forward answers to these questions, then this session will be useful for you, where my dependent variable is a binary variable. I hope you got the clarity about the problem which we are going to talk about. Okay? Yes.
So you mean to say that banks also use this kind of problem while accepting the loan application of a borrower?
Might be, I don't know, because no banks reveal what they do.
Okay.
But they can make use of it. Maybe they might be using it. I'm not aware of it, because nobody will reveal what they are doing. Yes, I think somebody is trying to say. Okay. My problem is very simple, and okay, let me take a simple example. Suppose we have to decide whether a customer should be given credit or not. Okay, so we define a dummy variable. Let's call it credit. If it is 0, that means no credit to be given to that person. If it is 1, we say yes. So credit will be a function of a number of variables. Let's call it alpha plus beta 1. Can any one of you give me any variable on the basis of which you will decide credit worthiness of a person?
Income.
Past repayment track.
Income, sir.
CIBIL score.
Employment.
Credit score.
Repayment track.
Then salary, income of that person.
Okay.
Credit score.
Right. Let me take only 3 variables, right? Plus the error term. Okay. It's a simple regression model, right? Why can't you use OLS? Simple ordinary least square module. You apply and you get the result. Can you do that?
So because here credit has 2 categories, it is binary in nature.
So what? क्या problem है? कर लो. OLS में क्या दिक्कत है? Estimate तो आ ही जाएंगे ना?
But sir, फिर जो credit वाला variable है, उसमें तो yes no type आएंगे ना answers. So how will we incorporate that in OLS?
Zero जैसे y को आप treat कर रहे हो वैसे इसको भी treat कर रहे हो, क्या दिक्कत है?
But sir, that 0, 1 is not representing the nature. That is representing the nature. It is not the numerical measure. It is representing the nature of the variable.
But for OLS, they are simply 0, 1.
So sir, that will not give us the correct results, no? क्योंकि वो तो OLS उसको mathematically treat कर लेगा, वो उसको
तो गलती
qualitative नहीं लेगा.
मानसी मैं ये जानना चाहता हूँ कि गलती क्या होगी, क्यों, किस बेसिस पे आप कह रहे हो कि करेक्ट रिजल्ट नहीं होंगे, क्या गलती होगी उसमें?
So it will be violating the assumptions.
कौन सी assumption वायलेट होगी?
So I'm not able to place exactly, but I know it is the violation of the assumptions.
हाँ, पर क्यों वो वायलेट होगी assumption?
Yes, sir.
Sir, all the independent variables are related.
All independent variables are related?
Yes, sir.
No. Repayment track may not be related with the income and the credit score, assuming they are not related. Still, you will have a problem, as Mansi is saying. Aru, क्या problem होगी? जब तक आप प्रॉब्लम को अप्रिशिएट नहीं करोगे, सोल्यूशन नहीं निकलेगा.
Sir, if I use OLS, for example, income may influence on credit.
Right.
But if I do binary, when I do this in logistic regression, I can know that on which income class have effect on credit. For example, income I have 4 categories. Less than 10,000, 10,000 to 20,000 rupees, 20 to 30,000.
Okay.
If I do binary, I can know that under which income, which under variable income, which income class will affect the credit.
Suppose income is not the categorical variable, it's a actual income. Whatever income is there of the person. Everything is at a scale level, not the category level, except the dependent variable. I'm sorry, any participant who doesn't understand Hindi, because in between I'm talking Hindi. So if people don't understand Hindi, then I will stop, pitching in Hindis here and there. Organizers, are you aware of people who don't understand Hindi or koi problem? Okay, anyway, don't worry. We have to first understand the problem and then we will try to find out. Why this separate topic? Because using OLS will give us problems and we have to take care of those problems. And therefore, you need a different set of tools and separate methodology to come out with the solution for these kind of problems. So if you're looking for the answers to these questions, we should study what is called a linear probability model, logic model, and profit model. And that's the agenda for this session, for this particular session. So we have a regression model where my dependent variable is a dummy variable. It may be dummy, it may be qualitative, it may be binary, limited, whatever name you call it. The fact is that dependent variable is taking only 2 values, 0 and 1. Okay, so first, and that will take us to the discussion on linear probability model, profit model, logic model, and others. So first we will start with the linear probability model. So modeling with qualitative and limited dependent variables. Let's consider a problem that the person has taken exam data about bankrupt firms and sound firms, and these are the ratios which have been collected. So the model will be the group. 0 means the company is bankrupt, 1 means the company is sound, and that. And we apply OLS, and we get an estimate, and the estimate is coming to be 0.75. What does it mean? How do we interpret this? How we will interpret this number when you get for the estimates. Estimate may not give you the exact 0 or 1. It may give you some value between 0 and 1.
So it is closer to 1.
Pardon?
It is closer to 1, so we may consider it considerably sound.
That's true, but what 0.75 means? इसका interpretation क्या होगा? What does it indicate? That is something which we have to understand.
That's why we don't use the OLS.
Yes, so because over here 0.75 will not make any sense. It will not point out to any category of the dependent variable.
No, this is not the reason for using OLS. We don't use OLS because of some other reasons. Okay. So when you use OLS, what you get, the expected value of y given xi. That's. And how do we get the expected value of given xi? I have to calculate the expected value of yi. So I need probability. It may take a value 1 and 0 and 1. Probability of success is normally represented by P, and the failure will be 1 minus P, and then VI probability into VI 0 P. So the expected value of Y given X will be P. And what is P? Probability that the variable will take a value 1. So when you get 0.75, it represents that there are 75% chances that the variable will take a value 1, or 75% chances are there that the company is a sound company. So the estimated value which we get, that is interpreted as probability of success, probability that my dependent variable gets a value 1. That's how we understand this. So expected value of yxi is nothing but the expected value of the value of yi given xi, which is nothing but the probability that y will take a value 1. Alternatively, the expectation of yi given xi can be calculated as this, 1 into probability of I, 0 into this, and that's equal to this. So that means what? The estimated value which we get is nothing but P, the probability that y will take a value 1. That's how we interpret this. So the estimated value is interpreted as the probability of having yi as 1. The marginal interpretation of the coefficient of xi is the marginal increase in the probability that a particular y takes a value 1 for 1 unit increase in x. And since we are determining the probability of y through a linear model, it is called linear probability model. And the estimated method is OLS. Okay. So for a given x, you see xi you have here. So given xi, this is the estimated value, which is also equal to p, and that's equal to 1 minus p. That's what I'm trying to say. That's equal to p, that's equal to 1 minus p. Okay, so if you are working with this kind of a model and you get the estimated value, which is equal to 0.80, 0.40, 0.25, all this represents probability that my y is taking value 1. So 40% chances are there that my dependent variable getting a value 1. That's how we interpret the estimated values which we get through regression. Is that clear or not? You please let me know.
Yes, sir.
So take it granted, the model with which we are going to work, its estimated values are nothing but the probability that y is taking value 1. Okay, now let's see what problem this model creates for us. It's a linear module, and it's monotonically either increasing or decreasing. So it may result in situations where the probability is becoming less than 0 or more than 1. And if it is so, then we find difficulty in interpreting the results. So it's a linear estimate, so it might give you values, more than 1 or less than 0. That might be possible. And we have nothing in this model to take care of it. That's one of the problems which we face when we use OLS. Another problem. Distribution of the error term is not normal because yi distribution, yi is binary, and it follows a binomial distribution and not the normal probability distribution. That's again, we face a problem. Okay. Now, since it follows a binomial distribution, can any one of you tell me what is the variance of a binomial distribution? What is the variance of the binomial distribution?
Sir, n into p.
That's the mean, NPQ.
Sir, NPQ.
NPQ, sir.
NPQ.
Right. Right. What does it mean? As your n changes, variance changes. That means your variance will not be constant, and you face heteroscedastic problem or heteroscedasticity. That's another problem. Error term may be following heteroscedasticity. So the values will not be lying in 0 and 1. What we need, we are looking forward nonlinear relationship so that my values always lying between 0 and 1. Okay, so if you use OLS, we face a lot of problems. One, probability values cannot be restricted between 0 and 1. Second, we find problem of non-normality. And third, error term may not be homoscedastic, it may be heteroscedastic. Because of those problems, we don't use OLS. In fact, we look forward non-linear relations. Now the question is, what are those non-linear functions which gives you value between 0 and 1 always? Anybody guess, anyone who knows any function, if you change your x from minus infinity to plus infinity, value will always be lying between 0 and 1. Any one of you can recall any such function they have come across? Whatever value of x you will take, the result will always be between 0 and 1. Okay, let me share with you one function. Y is equal to 1 over 1 plus e to the power minus x. So tell me, if x is tending to minus infinity, what will be its value? What will be the value of y?
0.
0. Good. And if x tends to plus infinity, the value of y will be
1.
1.
That means whatever value you take between minus infinity and plus infinity, the resultant value will always be between 0 and 1. So this is one of the function which is a nonlinear function, can be used to model our regression model where we have y as binary variable. Okay, we have a specific name for this function. Any one of you can tell me what is the name of this function? This is called
Is it sigma?
huh?
Sigmoid? Sigma?
No. It's called logistic function. We have another name for it. It is also called sigmoid function. And these functions are called S-shape functions because they take a value like this, S-shape. Okay. If I draw a cumulative normal distribution curve, how it will look like? If you draw a normal cumulative function curve, normal distribution, cumulative. So you'll find the value between 0 and 1, plus infinity and minus infinity. Can any one of you imagine? It will be again S-shape. Whatever value of x you take between minus infinity and plus infinity, this will always give you a value which will be lying between 0 and 1. Okay, so we found two nonlinear functions which will help us in getting always our probability estimates of the module between 0 and 1. And that's something we were looking forward. I mean, the sine function is not giving you value between 0 and 1 because sine function is something like this. It may take negative values also. Of course, it will not take value more than 1, but it can
I
take
mistakenly wrote that was sigmoid function actually, sir. Sorry.
Okay. Okay. So how to ensure the choice of P within interval 0? In this regard, two widely used approaches exist. One make use of the logistic function and another is standard normal probability distribution. And by using these two functions, we can model our problem. So if you use logistic function, we come out with what is called logit model. And if you're using the normal probability distribution, we come out with probit model. Okay. So if you make use of normal probability distribution, you will come out with the probit model. Logistic, you will come out with the logit model. So let's start with the probit model. That's how the functions looks like. Normal cumulative distribution function. Making a linear probability model, the probit model assumes that underlying distribution is cumulative standard normal probability distribution. Note that it's a nonlinear function, always takes a value between 0 and 1. So we get this. What does it mean? We define a function z is equal to alpha plus beta 1 x1 plus beta 2 x2 plus error term. Okay, z is my binary. Estimate the value of z. Put it in the normal cumulative probability function and you will get the probability. Probit model expresses the probability P. A dependent variable y takes the value 1 for given xi. And that's how we get the probability P. So the estimated equation which you will get, from that you will get z, and z corresponding to that use table to get probability. And this capital F represents the cumulative normal probability distribution. And this, or you can call it F Z, the estimated Z is called the normal equivalent deviate or normant. And since it's a nonlinear function, so we use maximum likelihood method. We cannot make use of OLS for the estimation purposes. Now let's start with the logit model. The underlying distribution is the logistic function or sigmoid function, which is like this, S shape. Which takes value between 0 and 1. And note again, it's a nonlinear function which restricts the value between 0 and 1. And logit model expresses the probability P that a dependent variable y takes value 1 given xi. And that's the function which we get. So instead of minus x, we use minus z, and we get z, which is equal to the estimated value. That is, z is equal to alpha plus beta x plus error term. This is the estimated value of the z hit. Okay. So if PI can be shown as this, and z is estimated as alpha plus beta x1, beta 2, x2, and so on, then we get the probability I. And if you, this, it can be shown that this is equal to this, and this is equal to this. What does it mean? Let me explain what I'm trying to say. So the moment you say Pi is equal to 1 over 1 plus e to the power minus z, that's equal to 1 plus e to the power minus z is equal to 1 over Pi. E to the power minus z is equal to, this will be minus 1 Pi 1 minus Pi, and if you take the reciprocal of it, you get e to the power z, and that's equal to Pi over 1 minus Pi. And this is called odd ratio. Okay, so basically it's a proportion between Pi and 1 minus Pi. So if I say the odd ratio is 4, what does it mean? If I say my odd ratio is 4, what does it mean? Success has 4 times more probability than failure. Okay, which means P is equal to 4 by 5 and 1 minus P is equal to 1 by 5. So P is 1 minus Pi. The proportion is 4 is to 1. So 4 is called the odd ratio. How many times success happens as compared to the failure? And that's what is called the odd ratio. So I repeat, because odd ratio is quite used in the logit probit model. Odd ratio is a probability of success divided by probability of failure, or P over 1 minus P. So if it is going to be 3, that means success is 3 times more likely than failure. If it is 1, that means there are equal chances of success and failure. Okay? And if I take a log of it, I get log of Pi, log of odd ratio is my z. And that is called the logit, and model is known as the logit model. That's my logit model. So get an estimate of z that will be equal to this, and from this you can get Pi. that will be equal to 1 over 1 plus e to the power minus z, or e to the power z upon e to the power z plus 1. They are same, no difference. And estimation method, of course, is it's a non-linear, so we are using the maximum likelihood method. Can we predict who is going to have value 1 and who is going to have value 0? Yes, for that we use some threshold, and most of the softwares are using threshold of 50%. So any probability more than 50%, that means it is success, and any number getting probability less than 50%, we are calling it as a failure. 50% is a threshold that is arbitrarily defined, but what is threshold for your problem, you have to take a call on it. Our next challenge is once logit probability model is fitted, then the question arises how to know the best fit of the model. Okay, so friends, what I do is let me stop it for the time being and see what we have discussed so far in our session. So we said that y is equal to alpha plus beta 1 x1 and so on plus error term. This is my binary. We cannot make use of linear probability model because of problems in estimates. The probability may be more than 1 or maybe less than 0, that's quite possible. Normal distribution is not there, and variance may not be constant. Okay, we also said that the estimated value which we get, that will be interpreted as probability of y taking value 1 and to take care of linear probability model problems, we look forward the nonlinear problems, nonlinear models, and in the nonlinear models we discuss the probit, which is based on normal distribution, and the logit, which is based on logistic. Both are nonlinear and they are being used, they are being estimated by making use of maximum likelihood method. Okay, and then we said that to make a forecast where one observation belongs, we have to define a threshold, and threshold normally we define as 50%. More than 50%, that means it belongs to 1. If it is less than 50%, we say it belongs to 0. That's arbitrary threshold. You can take any threshold depending upon your purpose. Right? So these are the things which we have discussed so far. So we can have a break here, and after the break, we will continue with our discussion. Any quick question if you have?
So can I ask something?
Yes, Mansi, please go ahead.
So, like if we have a Likert scaling type of problem,
right,
and we want to use that particular variable in the dependent variable, so can we go for either of these?
No. The value of the the value of the Likert scale is not 0, 1.
Yes, sir. Yes, sir. It can be up to 5 point also.
Whatever it is, I don't know, but that's a scale level variable. So
Yes,
you
sir.
can use ordinary situation.
Okay, sir. Thank you, sir.
This is only for those cases where you have binary variables.
Okay, sir. Thank you, sir.
Okay. Anybody else? Any other question?
Sir, I can use this model in deciding whether the admission should be given to the student or not.
Yes, you can.
And the factors may be 4 or 5 on the basis of which I may
You take. You can take their performance in the class 10, class 12, their performance in the graduation, their performance in the JD, their performance in personal interview. You can take their family background. You can take their family income. You can consider a number of variables. Yes, there you can make use of.
Right. Thank you.
Anybody else? So let's have a break and lunch break. And after the break, we will come back and start continuing our discussion. And organizers, please let me know when we will start next.
Sir, please you tell your time, like it's at what time it will be comfortable.
What is the time now?
So normally we provide the 1 hour break. So
let's give 1 hour break.
Okay, sir. So dear
2:45?
participant, yes, sir. Yes,
2:45?
sir. Yes, sir. Yes, sir.
Okay.
So dear participant, thank you so much to be with us. We are going to start our session, third session at 2:45 p.m.
Okay.
Okay. Dear participant, I'm going to share the feedback link also. I'll share the feedback link in a third session for the second session and the third session both.